7, I'm taking a very algebraic approach. It's not the only way, but it's the way that I'm going to solve this. So first of all, I'm going to draw a parallelogram DEFG. And it says D is 1/8 the size of G. So it's a pretty exaggerated parallelogram, I guess we could say. And so D is really small. I'm going to call this D, and then E, F, and G. Now there's some things that we know about parallelograms. We know that opposite angles are congruent to one another, okay? So we know that. We also know that adjacent angles, in other words, like D and G, would add up to be 180 degrees. What else do we know? Obviously, opposite sides are congruent as well. But at this point, we're mostly interested in the angle measures. So the first thing I'm going to recommend is that we just translate this into an algebraic equation. Angle D, so we're going to say D equals 1/8 of G. And I'm literally using D and G as my variables. Why not, right? Okay. And the next equation I can write is that D plus G equals 180. I just mentioned that just a moment ago. D plus G is equal to 180. All right, so now I'm going to use substitution. I know that D is equal to this, so I'm going to substitute that right in here. So I get 1/8 G plus G is equal to 180, which gives me 9/8 G when I add those together. 9/8 G, because this is like 8/8, right? Okay, you see that? Is equal to 180. Now all I have to do to finish this out is just multiply this by the reciprocal to get rid of this. So if I'm going to multiply this side by 8/9, I also have to multiply this side by 8/9. So these cancel, and I'm left with G. 9 into 9 is 1. 9 into 80 is 20. 20 times 8 is 160. Angle G is equal to 160 degrees. All right, which means that angle E is also equal to 160 degrees. So we can say angle G equals angle E equals 160 degrees. Okay, and then we can say angle D equals angle F equals, and if you take 1/8 of 160 degrees, I hope you can see pretty quickly that that's equal to 20 degrees. So there you have it, number 7.